I'm Professor of Environmental Science in the Hawkesbury Institute for the Environment at Western Sydney University. As a research scientist, I explore climate change impacts on native and urban ecosystems, particularly the roles that forests and trees play in mitigating climate change. I am pleased to contribute to this course. In this presentation, I will guide you through the science of climate change in an Earth system context. I will explore three topics. First, I will address climate change in the context of sustainability. Second, I will discuss the greenhouse effect and why it matters. And third, we will finish by examining the historic and contemporary record of climatic changes. My aim is to provide you a summary of the major climatic change drivers and a context to aid your thinking about risks and potential impacts on the assets, services, or functions in your organization. So let's begin. First, we should consider the fact that climate change is ultimately linked to a range of sustainability issues. These include increased use of our natural resources to meet the demands of a growing population, the expansion of industry, and the globalization of trade and commerce. All of these drivers increase pressure on our native and managed ecosystems and the services they provide, including climate services that maintain a self-sustaining and regulated climate. Put simply, the outsized influence of human activities is increasingly altering the way our planet functions. The scientific evidence is clear. According to the Intergovernmental Panel on Climate Change in its fifth assessment report in 2013, warming of the climate system is unequivocal. And since the 1950s, many of the observed changes are unprecedented over decades to millennia. The cause of human-driven climate warming is anchored in the physics of the greenhouse effect. Rising concentrations of heat-trapping gases such as carbon dioxide, methane, and nitrogen oxide, as well as other trace gases, in effect amplify the retention of heat at the Earth's surface, making our climate warmer. Over the last 800,000 years, the concentration of carbon dioxide has waxed and waned naturally over repeated ice ages, within a range of about 180 to 280 parts per million in our atmosphere. Incidentally, this amazing record has been revealed in tiny air bubbles trapped in ice cores in Antarctica, accumulating over millennia through snowfall and ice formation. In the past, this pattern was driven by the orbital mechanics of our planet. But this all changed following the Industrial Revolution and acceleration of fossil fuel use some 200 years ago. In January of 2020, concentrations of carbon dioxide reached 413 parts per million, nearly 50% higher than levels at the advent of the Industrial Revolution. Carbon dioxide circulates naturally in our Earth system. Green plants require carbon dioxide to grow. In fact, forests absorb roughly 60% of our annual carbon dioxide emissions from fossil fuel combustion. This is a huge service, but will our forests be able to absorb rising levels of carbon dioxide on into the future? This is a pressing question. Grounded in great research conducted here at Western Sydney University discovered that our native eucalypt woodlands may have limited capacity to absorb rising levels of atmospheric carbon dioxide. If this finding holds true more generally, our forests may lose their effectiveness to act as a green sponge for rising carbon dioxide levels. And just as a saturated sponge loses its ability to absorb more water, a saturated carbon sink in our forests means our forests won't keep pace with the increased carbon dioxide emissions. This would lead to an acceleration in the rate of accumulation of this major greenhouse gas in our atmosphere and amplified climate warming. A tipping point. Without doubt, the evidence is clear that over the past 3 decades, both land and ocean surface temperatures have risen. The data shown here represent globally averaged temperature increases compared to a 30-year reference baseline over the years 1960 to 1990. We can see natural year-to-year variation in temperature. However, the sharp upward trajectory in temperature is clear evidence of human-caused warming. Though land and sea surface temperatures are warming, The magnitude of warming is uneven across the Earth's surface. Warming in the upper latitudes, particularly in the northern hemisphere, is much greater than temperate or tropical latitudes. This is entirely consistent with predictions based on greenhouse warming. A warmer planet means more dynamic weather and complex shifts in seasonal rainfall patterns and amounts. Observations over the past century show certain regions received more rainfall, those are shown in blue, others received less, shown in brown, in comparison to long-term averages. Changes in the frequency or severity of droughts and floods can be important climate risk factors in some regions. The melting of polar ice, particularly land ice on Antarctica and Greenland, as well as the thermal expansion of water in warming oceans, have resulted in rising sea levels. In fact, since 1880, sea levels have risen on average 20 centimeters worldwide. Rising sea levels increase the risk of storm surge damage to beachfronts and low-lying coastal areas during king tides or cyclones. And finally, a warming climate means we can expect more extreme weather events today and in the future. Warmer oceans fuel stronger cyclones before landfall. Warmer land surfaces mean an increased frequency and severity of heat waves. Heat waves, when combined with drought, create conditions that promote bushfires. In summary, I hope that I've convinced you that climate change is best considered in a sustainability context. We briefly explored the greenhouse effect and its consequences for the functioning of our Earth system. Certainly, the observed record of climatic changes provides evidence of unprecedented warming of land and oceans, rising sea levels, and climate extremes. These and other changes pose clear risks and potential impacts on public assets, services, or functions. Thank you for watching.